All right. So we have something called Hall EMF that happens when we have current moving through different types of conductors. That is represented by epsilon, which is kind of a fancy looking E, almost looks like a backwards or upside down 3. That's going to come from the magnetic field multiplied by the length across the conductor multiplied by the velocity, drift velocity of the electrons. So only real problem we're going to have here is that this is in millimeters and this part's in meters, and those don't fit well with the units built inside of a Tesla. So we need meters. There are a few different ways to do this one. Probably the most concise one. We haven't done it this way before. But milli means 1,000th part of. That's the same as 10 to the negative 3. So that might be the easiest to set up here. Again, we have about a half a Tesla, so a pretty big magnetic field. The length here, 3.95, and then millimeter means times 10 to the negative 3 meters. If you don't like that, then you can divide by 1,000 or set up a conversion fraction or bump 3 times. It is also the same as 0.0395 meters. So that's the same thing if you prefer not to use the scientific notation. Then the velocity here, 7.45 meters per second. Now the meters squared and the per second cancel most of what's inside the Tesla, and as it turns out, all that's left over is volts. Then running these numbers through a calculator, 0.0154 volts.